Hello everyone, this is Mr. Teen Tutor here, and today we will be talking about the cross product. First, let's look at the definition of a cross product from a graphical standpoint. Let's say I have vector A and vector B. When we take the cross product between vectors A and B, which is represented like this with a multiplication symbol in between the two vectors, we obtain a vector that is perpendicular, and this is meant to be a straight vector here, a perpendicular vector to vectors A and B. So unlike the dot product, which is what you learned before the cross product, hopefully, you obtained a scalar, which means that you obtained a number. If we were to take the cross product between two vectors, you would multiply their x's together, their y's together, and their z's together, and then you would sum those three values together. In the case of the cross product, you don't obtain a scalar. Rather, you obtain a vector. So a classic example of a cross product is this. We have the 3D axes now, x, y, and z. So here is the example. Let's say I have vector 1, 0, 0 along the x-axis. And then let's say I had the vector 0, 1, 0, which is along the y. If I take the cross product between this vector and this vector, I then obtain 0, 0, 1, which is a vector along the z-axis. And if you look at that vector along the z-axis, it is perpendicular to both the x vector and the y vector. In essence, that's what the cross product is. Once again, it is a vector that is derived by using determinants and matrices, which we will go over in a little bit, and that vector is perpendicular to the two vectors that we started out with. So let me erase these two illustrations here, and then let's get right to this example problem right here, where we have defined vector A as 3, 5, -1, and vector B as 2, 7, 4. As I said, you will need to know how to work with matrices and determinants. Let's quickly go through how to find the determinant of a 2x2 matrix, which is what you'll be working with in order to solve cross product problems. So hopefully remember this. If you don't, that's okay. I'm going to go through it right now. If we wanted to find the determinant of a 2x2 matrix, as is shown right here, A, B, C, D, we take the product between A and D, and write it as AD. Of course, you can write it as DA because, as you know, multiplication is commutative, minus the product between B and C, which I will write as BC. That's how you find the determinant of a 2x2 matrix. So let's do this example problem right here. So we need to find a vector that is perpendicular to both vector A and vector B. And as you know, I wrote it in this form, but you can also write it in IJK form. For example, vector A in IJK form would be 3i plus 5j minus k. Now this is important to note. Make sure you guys get this down. When you're taking the cross product between two vectors, it's important that you write the components of the vector that is to the left of the multiplication symbol first. So because A is first, we say it's 3, 5, and then -1. And then B, which is to the right of the multiplication symbol, we will write its coefficients in the second row here. Technically the third, but we'll just say it's the second row. Understand that A cross B is not the same thing as B cross A. In fact, I'll just write this property right here just so you know it. A cross B is equal to the opposite of B cross A. So the cross product is not commutative. The dot product is commutative because, as you learned, A dot B is the same thing as B dot A. Unfortunately, that's not the case with the cross product, which is why it's imperative that you write down these components correctly. So let's go through now how this works. So this is going to be equal to a 2 by 2 matrix here for I, and it's always going to be minus J, something J, plus K. So this is another thing you need to get down. Make sure you write it in this form. It's going to be some 2 by 2 matrix I minus some 2 by 2 matrix J plus some 2 by 2 matrix K. So if you remember from your matrices unit, in the event that we have this type of matrix, in order to find, for example, the 2 by 2 matrix for I, we ignore the column with I and the row with I. And when we do that, we're just left with these four numbers right here. So therefore, we have 5, -1, 7, and 4. For J, eliminate the J column and the J row, and you get 3, -1, 2, and 4. And lastly, if we eliminate the K column and the K row, we are left with 3, 5, 2, 7. What we need to do now is we need to find the determinants of each of these matrices. So let's do exactly that. So this is going to be 20 minus -7 minus, in parentheses, 12 minus -2 J plus 21 minus 10 K. So if we simplify each component, this would be 27I minus 14J plus 11K. So this is the vector that is perpendicular to vector A and vector B. Now you might be wondering how you could check your work. Well, here's one big way of doing so. You know the definition of cross product. Therefore, think about it now in terms of dot product. You know that the dot product between two vectors is 0 if the vectors are perpendicular to each other. So let's test the dot product between A cross B and both vector A and vector B. So first let's do A cross B dotted with vector A. And that should, we'll see, but it should equal 0. So if we do the quick calculation, we get 0 when we dot it with vector A. And if we do A cross B with vector B, it should also be 0. Again, let's check. And it is. So this is the correct answer because this vector, by definition, is perpendicular to vector A and vector B. In terms of application problems, there are a couple of application problems involving the cross product. And one of them, for an example, is the area of a parallelogram. So let's look at our answer here for a second. Let's say I have these two vectors again, A and B. Well, hopefully you guys are familiar with the parallelogram rule or law involving vectors. So like here's vector A and here's vector B. As you know, this is the resultant between A and B. And again, this is vector A and this is vector B. And though my picture is not perfect, the idea is that this forms a parallelogram. So here's the nice thing. If we wanted to find the area of a parallelogram, this is how you do it. You take the magnitude of the cross product between A and B. So let's say this was a parallelogram with vector A being 3, 5, -1 and vector B being 2, 7, 4. So all we have to do is we need to find the magnitude of this vector, and that gives us the area of the parallelogram formed by vectors A and B. So let's quickly find that. So this would be 27 squared plus -14 squared, or you could write 14 squared because, as you know, anything to an even power is still going to be a positive number, plus 11 squared. And I apologize for my square root symbol. It's not that perfect. But the idea is that you're taking the square root of the sum between 27 squared, -14 squared, and 11 squared, because again, that is the definition of the magnitude of a vector. So let me quickly calculate this. And the answer is the square root of 1046, which in decimal form is 32.34 units squared, because as you know, we're finding the area of a parallelogram, so the area is expressed in units squared. So I hope this video helped you. I hope you now understand what the cross product means and how we derive the cross product and an example of an application problem involving the cross product. It's not a terribly hard concept, but if you are in multivariable calculus, for an example, right now, it's important that you understand this concept because this concept will be coming back later on in future units. Alright, so I hope this video helped you. Thank you very much for listening to this video. Mr. Teen Tutor, out.